Okay guys, sorry I had to cut the last video a little shorter than I wanted to, but these next few slides are kind of hard to watch. If you don't like blood, or you get grossed out easily, or you're just super tender-hearted, you may not want to watch this video that I'm about to play. But this is going to kind of go again to show the amount of plastics and pollution that is in our oceans and some of the results from it.
I'm coming. You can go for it, Mr. Surgeon. Going to be so happy.
Bless you.
Have you ever heard of that too?
You know what this is?
What is it?
Green.
Yeah, could you, one of the swaps, the sterile swaps, could you put them into the iodine and then we're just gonna try to clean it?
Sí, yo lo intentó. Sí, yo ahorita lo mordí. Yo lo mordí ahorita y es plástico.
He bit on.
So, you can see it affects marine life in a lot of different ways. I mean, when you can see the turtle literally crying in pain, that's what really gets to me and kind of makes you take a step back and realize the effect that we have on the environment. So, there is something called the trash island, and it's over a mile across or a mile wide, however you want to look at it, that's floating in the middle of the ocean. Two of these pictures are showing this huge, enormous trash island. And the thing about it is it's not just like plastic bottles and stuff sitting there. The plastic has started to degrade and rot to an extent, and it's just like thick sludge. Scuba divers have tried to swim through it and investigate what's going on underneath, but it's almost like a disgusting thick sludge of just garbage. That other picture with all the tires, I couldn't tell you where that's at, or the insane, ungodly amount of just tires that have been dumped into the ocean. So these are huge problems, because cleaning something like that trash island, I don't know that we're prepared for it or have anything that would reverse that. But things like this, unfortunately, are starting to become more and more common. Instead of being the exception, they're starting to become more of our reality. So here's kind of a hot button issue with global warming. Global warming, the way people come about it and try to say that it's not a thing, is we do have proof of it. It is a thing. Where the misinformation ends up happening is when we say global warming, we're not saying that the Earth's temperature is spiking like that, like crazy, and we're going to burn to death or something like that. What you have to take into consideration with global warming is Think about the freezing and melting point of water. They're the same. Okay? 0 and 32 degrees Celsius and Fahrenheit. So that means that 1 and 33 degrees, you have water. Going back to 32 and 0 degrees, you have ice. It's a 1 degree difference that causes that state change in matter. This is why global warming is an issue. We don't have to skyrocket the temperature of Earth a bunch of degrees in order to have some type of catastrophic effect. 1 degree difference is all it takes for ice to melt and become water. So that's why this is such an issue. Global warming is going to be due to greenhouse gases like carbon dioxide and methane being trapped in our atmosphere. Our atmosphere is awesome for us because it keeps the warmth in, but it also doesn't allow any warmth to escape. And because it doesn't allow any warmth to escape, it's going to keep that heat trapped in, which is what the gases like carbon dioxide and methane being trapped in will aid in doing, and that's how you have that greenhouse effect. So keep in mind, it's not about Earth heating up and heating up and heating up and there being like this huge, insane difference in temperature, but it's just that 1 little degree change. And it's changed more than just 1 degree. I know part of the pictures are cut off, but on the left-hand side, the very first picture is from 1984. The other one is from 2012. And then you can see the dates on the other pictures of 1979, 2011. Now, that may seem like a really long time, but truly, it's not. And then we've got ozone depletion. Now, our ozone layer is part of our atmosphere, which again is like a super awesome thing that we have. The ozone layer is basically Earth's equivalent to having sunscreen. It's going to be what protects us from harmful ultraviolet rays from the sun. And our ozone is thinning, and there's a big, giant, gaping hole in it that didn't used to be there and is totally not supposed to be there, like, at all. So, again, you can see the pictures. Some of them are cut off at the bottom. Sorry about that. But we've got some major issues with our ozone layer. Think about it like, again, sunscreen. If you put sunscreen everywhere, but you leave a spot forgotten where there's no sunscreen on it, that part's going to get roasted. So our ozone doesn't do us as much good having a big gap in it. And things like chlorofluorocarbons, also known as CFCs, those are going to be things that eat away at it. If you're wondering what on earth did she just say, what's she talking about? It's a chemical that's usually found in aerosols. So spray paint, certain things like that, an aerosol can where it's pressurized. Big difference in our ozone. I think it's really obvious when you see the picture on the bottom right where you have that one where there's just a little tiny bit of dark blue and there's a lot of light blue, and then boom, big giant circle of dark blue. Looking at the dates, that first one's 1979, and I believe that other one says 1989. So it's just a 10-year difference that is made. So we really need to kind of get a grip on some of the things that we're doing, because scientists have literally tried to recreate ozone. What ozone is 3 oxygen molecules bonded together. So if you ever see an O with a subscript of 3, that's ozone. They've literally tried to make it and just like release it up into the sky and up into the atmosphere and hope that we can plug the hole up that way. But it doesn't really work that way. It seems like it's kind of repairing itself to an extent, but we're still doing enough damage that we haven't made a complete and total recovery here. So that's the end of section 1. And again, I know it's kind of rough to get through. There's a lot of not so fun, kind of ugly stuff to talk about in it, but this is the reality we live in. Our world is precious. It's the only one that we have and we're ever going to get. And we've not exactly done the best in taking care of it and prioritizing what we should. Humans like convenience. We like what's easy for us, and things like plastics, one-use items, and just throwing things in the garbage. It's easy and simple. However, there has been a much, much larger push for conservation biology in the last probably decade to 5 years. You're seeing a lot more green alternatives, recyclable stuff, repurposed things, and this is awesome, which is where Section 2 kind of picks back up and sort of restores your faith in humanity a little bit, because it shows some of the things that we're doing to try to kind of apologize and make amends and fix the mistakes that we've done and help our environment kind of heal and get back to where it needs to be. Okay, so let's jump right in and talk about what conservation biology is. It's going to be all about protecting biodiversity, which is something that we need and are super, super dependent on. Remember, biodiversity equals stability in ecosystems, and we have those 6 key benefits we get on it, which beauty and pleasure, food, helping food crops, resources, medicines, all sorts of stuff that our lives depend upon are built off of biodiversity. So this conservation biology is literally going to be to conserve and prevent the loss of members of species in their habitat. Conservation biology is actively at work right now. We've got legal protections not just in the U.S. but also in the world. You've probably heard of the Endangered Species Act of 1973, where it makes it illegal to harm, collect, harass, or disturb the habitats of threatened endangered species. Now, notice, it's not just about protecting the species, it also involves that species' habitat. And this is a key important part of this that I'm so grateful that they included. Because, okay, fine, we have an endangered species. Here's my little endangered species. It's all nice, safe, and protected. Nothing can go wrong with it. Where's it going to live? Where's it going to get its food from? Where's it going to get resources from? Sorry, she's crazy. If it can't have a habitat or an environment or a place to get resources from, there's kind of no point in conserving and protecting that organism. You've got to protect where it calls home and its comfortable spot too. So this is why habitat preservation is also important with conservation. So this is why habitat conservation is also important with conservation biology. You need to preserve where these organisms live and are native to, because a species just straight up cannot survive without its habitat. One of the super, super cool things that we have here are wildlife corridors. We talked about divided habitats earlier in the first part of this chapter. So these wildlife corridors are going to allow organisms to be able to cross things like interstates that would typically separate really, really large expanses of territory and give them a chance to not become roadkill, obviously. So you can see the pictures on the bottom. These are major busy highways and interstates, and these really cool kind of bridges would be the best way that I would describe them, are over this, where animals can cross protected and safe. They try to make them look as natural as possible, and I've got some other cool examples on the next slide of what those look like. Here we've got some more examples of wildlife corridors. Instead of this one going over the road, you can see it going underneath for several of these. You've got deer using one. That in the bottom left-hand corner is a lynx. You've got a cute little koala. And the one in the upper right-hand corner is probably one of the craziest ones I've seen, but those are actually crabs migrating. And this is like a huge, giant crab migration that happens every single year. So you can imagine people not wanting to run those over and have like a million squished little crabs underneath their car. Besides just preserving and keeping habitats safe, some habitats, like you saw with a lot of the ocean pictures, have already been pretty severely destroyed and messed up. So those that are hurting and damaged, we want to restore them and replenish them back to the point that they used to be, that organisms that living there are comfortable and thriving again. So this is taking a damaged habitat and trying to bring it back to a healthy condition. So here we've got an impacted area and a restored area. It may not look like that big of difference, but focus on the riverbed. In the impacted area, there's not as much thriving around the riverbed or the banks of the river. Fun fact, all those cool, like, Instagram-worthy pictures you see of people stacking stones in, like, cool little ways, or trying to get some artsy sunset picture with stacked stones. In things like national parks and protected areas, they're actually begging people not to do that. Because what you don't realize is when you're digging those stones up and you're disturbing that environment, there are lots of little itty-bitty tiny invertebrates and microorganisms that break down debris that gets in the river, and they're actually really key crucial parts to that ecosystem. They're also a super good indicator of the health of that ecosystem too. There are these little things called water pennies and all sorts of other crazy looking little invertebrates that pretty much just look like space aliens that are crucial to this freshwater ecosystem's health. And you don't want to mess those up, because as soon as you pull them up out, you've stirred up the bottom, you've disturbed them from where they are. They're either going to get washed downstream, they'll bounce against other rocks and get injured or killed, and they really don't want you doing this. So if you ever see someone stacking rocks, you may want to politely ask them to stop, because it's not very good for the ecosystem. Here's another area, and let me move my picture again down here. The most obvious thing to kind of keep focused on with how this one comes back is that kind of evergreen tree in the background. The first two pictures, they pretty much speak for themselves. That they look terrible. The soil looks horrible, like it's not in good condition. And then the final one where all the grass and the waters come back. This has been a fantastic job of habitat restoration. Here we have another couple of great examples of habitat restoration going on. You've got your timestamps of April 2007, April 2010, July 2008, April 2010, of just 2 years of letting nature do its thing undisturbed can do. And honestly, nature really truly is resilient when you let it be. Some of the kind of cool and sort of creepy things that you can look at are pictures of Chernobyl, where the nuclear meltdown happened with the reactor in Russia. They're kind of eerie, but looking at theme parks where it's like bumper cars or Ferris wheels just being completely overgrown by vines, or even New Orleans from Hurricane Katrina, where the levees broke and blocks were just completely abandoned, where you've got trees growing through houses, and nature is extremely resilient when you just kind of leave it alone and let it do its thing. So even though we've done some pretty terrible things to the environment, there is still a lot of hope out there. We've not gone probably beyond the edge of no return, but we like to flirt with that line a little more than we should.